4.4 Factoring Polynomials by Kevin, Alexiev, and Giannini. Core concept: special factoring patterns. Sum of two cubes, which is a to the third minus b to the third, which equals a plus b in parentheses times a squared minus ab plus b squared in parentheses. Example for that is 6 cubed plus 1, which equals 4x cubed plus 1 cubed. And then the sum of two cubes is 4x plus 1 times 16x squared minus 4x plus 1 in parentheses. And difference of two cubes, which is a to the third minus b to the third, which equals a minus b in parentheses times a squared minus ab plus ab squared in parentheses. An example for that is 27x to the third minus 8, which equals 3x cubed minus 2 cubed. Difference of two cubes, 3x minus 2 times 9x squared plus 6x plus 4. Finding a common monomial factor. 3y to the fifth minus 48y to the third, which equals 3y to the cubed times y squared minus 16, which is the factor once you factor the common monomial out. And then you find the difference of two squares, which is 3y squared times y minus 4 times y plus 4 in parentheses. Another one is x cubed minus 2x squared minus 24x. And when you find the common monomial, you get x times x squared minus 2x minus 24. And the difference of two squares is x times x minus 6 in parentheses times x plus 4. Factoring the sum of difference of two cubes. Let's start with x cubed minus 125, and when you write it as a cubed minus b cubed, you get x cubed minus 5 cubed, and the difference of two cubes is x minus 5 in parentheses times x squared plus 5 plus 25 in parentheses. Another one is 16s to the fifth plus 54s squared. And when you factor the common monomial, you get 2s squared times 8s cubed plus 27, and write as an a to the third plus b to the third, and you get 2s squared times 2s to cubed plus 3 cubed, and the sum of two cubes is 2s squared times 2s plus 3 in parentheses times 4s squared minus 6s plus 9 in parentheses. Factoring by grouping. Factor z cubed plus 5z squared minus 4z minus 20. First, you gotta factor by grouping, so we'll take out z squared and you get z squared times z plus 5 in parentheses minus 4 times z plus 5 in parentheses, and then we use the distributive property, which is z squared minus 4 in parentheses times z plus 5 in parentheses, and the difference of two squares is z minus 2 parentheses plus or times z plus 2 in parentheses times z plus 5 in parentheses, and y cubed minus y to the squared plus 6y minus 30, again factor by grouping. y3 minus 5y squared plus 6y minus 3 equals y squared times y minus 5 in parentheses plus 6 times y minus 5, and then we use the distributive property and get y squared plus 6 times y minus 5 in parentheses. The difference of two squares is 3y plus 3 in parentheses times y plus 3 in parentheses times y.5 in parentheses. Factoring polynomials in quadratic form. We'll do 16x to the fourth minus 81, write as a squared minus b squared. We'll get 4x squared in parentheses squared minus 9 squared, and then we'll factor again and get 4x squared plus 9 in parentheses times 4x squared minus 9, and then difference of two squares, we'll get 4x squared plus 9 times 2x minus 3 in parentheses times 2x plus 3. Next we'll do 3p to the eighth plus 15p to the fifth plus 18p to the second. We'll factor a common monomial and get 3p squared times p to the sixth plus 5p cubed plus 3, and we'll factor the trinomial in quadratic form and get 3p squared times p to the third plus 3 in parentheses times p to the third plus 2. The factor theorem. When dividing polynomials in the previous section, the examples had non-zero remainders. Suppose the remainder is 0 when a polynomial f of x is divided by x minus k. F of x divided by x minus k equals q of x plus 0 divided by x minus k equals q of x, where q of x is the quotient polynomial. Therefore f of x equals x minus k times q of x, so that x minus k is a factor of f of x. This result is summarized by the factor theorem, which is a special case of the remainder theorem. Core concept: the factor theorem. A polynomial f of x has an f of a factor x minus k, and only if f of k equals 0.